Hello friends, welcome to our channel. In this video, I would like to explain another topic based on the fixed beam. That is, fixed beam subjected to a couple applied eccentrically on the span. See here, this is the concept. For this, we have to find out the fixed movements. So, what are the fixed movements when a couple is acting eccentrically on the span? So, for it is what we have to find here. So, already in the previous videos, I explained so many videos based on the fixed beam. See here, this is our channel playlist. Here, a fixed beam carrying a point load at midspan and fixed beam carrying a concentrated load at the midspan. Again, uniform varying load. Again, uniform varying load with at a distance d. Uniform distributed load. And again, symmetrical triangular load. And again, one more video, I explained all the formulas for brief and quick revision purpose. And again, I solved some of the examples with respect to the derivations what I solved previously. But today in this lecture, I would like to explain another topic based on the fixed beam subjected to a couple eccentrically applied on this span. So first see the videos which already I explained, come order wise. So in the channel playlist also I kept order wise only. You follow that order for better understanding. Okay. Then I can move to the concept. See here, this is the couple which is acting on a fixed beam. Whenever a couple is acting, so you can observe one thing. Here the couple will be acting anti-clockwise, and there is a chance of acting the couple in clockwise also. First, for this you can understand the concept clearly. Whenever a couple is acting like this, the fixed line moments, whatever we are finding, you will get the reacting moments also in the anti-clockwise only. So if the couple is acting clockwise, so the reacting moments, whatever you are finding, you will get the clockwise only. So first you have to understand this one. So whenever a couple is acting, see here, a fixed beam AB is subjected to a concentrated couple at C at a distance A from NDA. So the couple may be taken here for finding this derivation. Here the couple may be taken to consist of two equal and opposite point loads. See here, this is one I am taking with small distance DA. We are considering two equal and opposite loads. Whenever a couple is acting like this, we have to consist of two equal and opposite loads at small distance dA. So this one will be small distance dA, but I am writing aside. And this distance will be A, already you people know. And this one will be L minus A, or in terms you can take L, A plus B. Okay. Then, so the total distance from here to here will be A plus delta A, here to here. And what is the remaining distance here from here to here? So we know this is the total span length of L. If you want to find this distance, you will get L minus A plus delta, means A minus delta A. You will get this one. Okay, I will take this one in the form of L minus A minus delta A, which is the form of A minus B whole square. A minus B format to solve this derivation. And again, one more thing what we have to observe clearly means, see here, whenever a couple, a point load is acting eccentrically on this span, like this. What is your formula for that one? So already I shown where I placed in the channel playlist. You can go and check once. Whenever a couple is acting, so your end moments will be, one will be acting anti-clockwise, another will be acting clockwise. So in the overall span length of here. So what are the fixed moments for this one? MAB. For AB, this equal will be MBA. For MAB, you will get WA into B square by L square. For the MBA, you will get W into A square by B square. WA square B by L square. See here, whenever a point load is acting, I told already, both will be acting anti-clockwise couplements, anti-clockwise only. So this is in the same format only. So for that one purpose, what you will take, MAB will be equal to first load, which is acting downwards and anti-clockwise. You will get one will be anti-clockwise. So here minus W into A B square by L square. Similarly, you will get here also in the form of summation for solving this point load downwards. But here another load will be acting upwards. So for that purpose, what you have to consider means you have to consider plus here. And again W into A V square by L square. So this one related to this W and this one related to this W1. Okay. There will be 2 point loads is acting. For example, if 2 point loads is acting downwards, at that time what we have to take? We have to take directly here minus W A B square by L square. Similarly, minus WA B square by L square. Okay, but here 2 will be acting opposite direction. Therefore, we are taking like this. So first you have to solve MAB. Then we can go for MBA. So it is always better to come step by step. Okay. So for this one, what is W here? Again, I am expanding this one. Here minus. What is W? W will be W only. And A distance will be here A only. And B distance here L minus A for first load by L square. Similarly, plus, and this W1 will be this W only. And again, this A distance will be A plus delta A. And B distance will be L minus A minus delta A. L minus A. I am taking this is one form and another one delta A in other form. Okay. So this one will be A square by L square. Okay. Okay. You can see here. Now you can solve your derivation. You can keep this one as it is like that only. Okay. Then plus W by L square. A plus delta A. And you can expand this term in the form of A minus B whole square. Okay. So you know the formula. What is your formula? A square means A square plus B square plus 2AB. Directly you can apply here only. A minus A whole square plus B square will be delta A whole square minus 2AB minus 2 delta A into L minus A. Okay. See here. Then again I am taking the value same here only. Again W by L square. And again, we are considering a small distance delta A apart here. You can see the diagram. We are taking this one more other opposite with a small distance dA. And again, if you see here, this delta A square will be very minor term. This is small part. Delta A square, delta A cube comes and again very, very small. Therefore, we are ignoring such terms. Delta A square and delta A cube. If you will get that one means you can ignore that one. And you can apply remaining terminology to this one. So A plus delta A L minus A whole square minus 2 delta A into L minus A. And again, you can expand this one W by L square. So I'm multiplying the entire term with first A and again delta A. A into L minus A whole square minus 2 into A into delta A L minus A. And again delta A into plus delta A into L minus A whole square. And again delta A into minus delta A into delta A whole square. Again, this term, if you multiply with this, you will get that one also 0 because delta A into 2 delta A. Automatically, it becomes delta A whole square. Then automatically, we are ignoring this term. So, no need to consider here. Okay, you simplify and you can make it as 0, no problem. Then, and again, if I am taking this term as it is, minus WA, so this term I am taking here, L square, L minus A whole square, plus I am taking this term, W by L square into A into L minus A whole square. And again, plus W by L square, and I am taking these two values as common, minus 2A delta A L minus A plus delta A L minus A whole square. So see here, one will be negative, one will be opposite. You can cancel these two terms and you can simplify here. Square. And again, what are the common terms you have to take? A. Sorry, delta A you have to take common. Delta A. Okay. And again, what are the common terms you have to take? L minus A. See here, and again, what are the remaining terms here? Minus 2 A delta A, 2A plus L minus A. Okay. And again, check once again. Is there any missing values here? W by L square delta A into L minus A. So 2A minus A, which is 3A, L minus 3A. So this is the value. And again, W into delta A. You can see here, you can observe very clearly what happens. W into delta A, W into delta A. Here the moment will be acting. Force into distance, W into delta A. So moment equal to W into delta A. You can subtract the word directly. And again, L minus part A what will be taken as B also if you want. Otherwise, you can keep like that only. Okay. So I will take this one as the movement part M naught by L square. And again, L minus A, L minus 3A. Okay. So this is the moment value for A, moment at A. Whenever a fixed, what is the fixed movements? Whenever a moment is acting eccentrically on the span, which is in anti-clockwise direction, means you will get the moment A will be this one. So if you want, you can take this L minus A as B also, no problem. Then you can move to the MB. For MB also, you have to take same value. I will simplify here aside for MB. See here, what is your MB? MB will be equal to, what is the general formula whenever a point load is applying like this? First you will come. So whenever it will be anti-clockwise means you will get plus W A B square by L square. Here also you will get both plus. It will be acting clockwise means, but it will be acting anti-clockwise and here downward load. So I am explaining here clearly. So we know eccentric condition. First you can take, and as per my logic, you can take like this. See here, W A B. So we know eccentric condition. One will be acting anti-clockwise, another will be clockwise. The formula here already this one will be completed. MBA will be equal to. So if it will be like this, clockwise and downward load, you will get plus W A square B by L square. But here, what is the condition? Downward load, anti-clockwise movement. So directly you will get as per our this concept condition, downward load, anti-clockwise minus W A square B by L square. And again, if a load is acting downwards and again clockwise load is acting, means what happens? You will get a plus W A square B by L square. But as per our condition here, anti-clockwise upward load is acting. So here clockwise upward load means you will get a opposite value. Sorry, here you will get a clockwise upward load. You will get negative here. Clockwise downward load you will get positive. Clockwise upward load you will get negative. But here you will get opposite. Anti-clockwise upward load positive. W A square B by L square. So just you can go as per your logic only. Only to bother here. So as per our logic, you will get one will be negative and one will be positive. So and again you can apply the condition W minus W. A value will be this much only. A value only. A square. B will be L minus A whole square by L square plus and again W by L square. You can take down this A square as this value for another load. A plus delta A whole square into what is the B value? So we know B value will be L minus A minus delta A. Okay. Then you can simplify this one as per our condition. So MVA. So I will keep as it is the same value here plus W by L square. And again, you can expand this one will be in the form of A plus B whole square. That one will be A square plus delta A whole square plus 2A delta A plus and again there will be two values L minus A minus delta A. So already I told you because of the small distance delta A we are considering, you will get delta A square terms, delta A cube terms. You can ignore these terms because of the small values 0. So I'm taking here this one as directly 0 and multiply first with the inter terms with this value and again multiplying with inter terms with this value. So take down the same value here and again place W by L square. So A square into L minus A plus L minus A into 2A delta A minus and again delta A into A square. Delta A into delta A square, delta A cube. Automatically we are considering 0 here. And again delta A into plus 2A delta A. Automatically we will get delta A whole square. Automatically, this one also it will become 0 because A delta A whole square, ignoring the term, you will get 0 here. So no need to consider this part. And again, simplify for the next step. Take down the values, what you will get here. So take down this value now here because it will be cancelled here. So if you follow the order, you will get direct values like this. Otherwise, you can simplify by your own. And finally, check the answer. Plus W by L square, A square into L minus A. Sorry, you can see one thing here. I am missing here. Here, W A square B by L square. You won't get this value here. Okay, L minus A only. So after simplifying, you can make it correct. Then automatically the two terms will be cancelled, which is L minus A into 2A delta A minus delta A into A square. So this term and this term will be cancelled. And what are the terms left over here? See here, W by L square. And again, what are the common terms we have to take outside? A delta A here, delta A here. And again, first you can take delta A. And again, A. See here. And again, what are the terms we have to take common here? W by L square, L minus A. So first you can take common here outside A into delta A. So if I am taking A outside, you will get one more A here. Sorry, 2 only. Delta A already taken outside. A delta A taken common outside. Only A will be there. So see here what are the terms? WA by L square into A. 2L minus 2A minus A. So if you simplify this one, W into delta A by L square, A into 2L minus 3A. So if you see here, MB part, MB will be equal to W into delta A already we taken, that is moment, by L square A into 2L minus 3A. So this is what your MA and MB will be, you will get like this. So your MA value will be M naught by L square, L minus A, 2L minus 3A. But your MB value will be M naught by L square, A into 2L minus 3A. Here already I told you, in place of L minus A, you can consider B also. So I will take down that value here. M naught by L square. So what is the value? A into 2L minus 3A. A into 2L minus 3A. See here, if you want, you can take down this one also. L minus A will be equal to B. So if you simplify your fixing moments, it will be equal to A and B. So these values. So whenever a couple is acting like this, which is anti-clockwise, and both reacting moments also equal to anti-clockwise. This is MAB and this one will be equal to MBA, which is acting eccentrically on the fan. But whenever it will be acting clockwise, So for this also, you can follow the same steps and same derivations. So it will be clockwise means both reactive moments you will get clockwise only. So already I explained the formula how we will get in the channel also. So here there will be one video. I think here for tutorial purpose in our channel only, I framed a video like this. So whenever a triangular load is acting, so your moment, fixed moment at A will be equal to 5 by 96 WL square and BA will be equal to 5 by 96 WL square. Similarly, if already now I explained anti-clockwise couple is acting. But here clockwise couple is acting, the formula will be, both will be positive signs only, but you will get both moments which is in positive term. MB by L square, 3A minus L. MA by L square, 3B minus L. Similarly, I explained previous videos also. See here, UDL, WL square by 2 plus W. So you please go and check this one and make a screenshot for quick revision purpose. So now we are in this topic. Whenever anti-clockwise movement is acting, both you will get anti-clockwise. But if a clockwise is acting, the formulas will be that one. So the entire procedure remains same. But here also you have to consider two opposite chores and you can follow the same procedure, you will get that answer. I hope you understand this one. So uh, derivation is somewhat tricky, but you have to practice so many times to make it easy. Thank you.